Alright, in this video I'm going to do homework problem 4.2, the first question, and so let's go ahead and get started. Actually, I need to turn that off. Okay, so it says a data set is given below. Draw a scatter diagram. Comment on the type of relation that appears to exist between x and y. Alright, so let's go ahead and we're going to go to, actually, this is probably one you can figure out just by looking here. It looks like these are going by ones, same thing here. I think on this problem I won't use that. I think we could probably figure it out. So we're at 5.2 at 1, so this looks like the 1 right here, and 5.7 doesn't look like we have that on any of the other graphs, so let's go ahead and choose that. You could do the graph like we'll do when we get to number 2. Let's go ahead and choose A here. So part B, there appears to be a nonlinear, linear negative. Well, I tend to think this is, we don't have a whole lot of points here, but let's see, we're missing a point here, we just can't see it, that's what it is. So we do have a linear relationship here. I was starting to worry there. And it is negative. So let's go on to the next problem, or next part. So let's see, for part B, determine the least squares regression line. So we're not going to do this by hand, so you can actually go ahead and go here, open in StatCrunch, and we're going to click Stat, Regression, Simple, and let's select our variables, and go ahead and click Compute. Let me make this a little bigger. So I'm going to go ahead and write this down. It's y equals, we're going to put the x part first, so negative 0.782 is what that would round to for 3 decimal places times x, plus 6.7128, so we'll say 713. Alright, so let's go back to the problem. So x, it's negative 0.782. And then, now if you put a negative number in here, if it's subtracted, you'll just put in a negative. In this case, it's 6.713. Alright, and then choose the correct graph below. Well, these were our points. Again, we can't see the whole graph, but there it is. And so it's got to be this one here. Those are the same points we picked in graph A. Oops, got to choose it though. So you can certainly look at your graph. I'll go back to what we had in my stat lab. If you go to the next page, you can see the graph and you could compare it. Let's go ahead and make it a little smaller. Oops, I'm trying to make it a little smaller here. Let's try that again. There we go. Alright, so you can see the scale looks a little different, but this is the graph here. And let's go ahead and check answer. And so that's question 1. I think we might as well go on to question 2. That didn't take too long. So complete parts A through H. So by hand, draw a scatter diagram treating x as the explanatory variable and y as the response variable. Choose the correct one below. So let's see, we are going by ones here, it looks like. So 2, 2 is here, and then 3, let's see, that doesn't look right. Are we going by ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7. Oh, I see. We need a scale of 20 in order to fit 717, so they're actually going by twos here. So 2, 2 would actually be right here. So 2, and that's 2. Because see, our scale's 1 on this axis and 2 on that one. So there we go. So 2, 2, 3, 5. So that looks right. So this is going to be the graph here. So find the equation of the line containing the points 2, 2, and 7, 17. So I'm going to switch to my paper. First of all, we need to find the slope of the line. So if this is the first point and this is the second, we're going to get 17 minus 2 over 7 minus 2, which is 15 over 5. Excuse me, or 3. And so now let's go ahead and use a slope of 3 and 0.22. We have y equals mx plus b. And so y is 2, the slope is 3, x is 2. So we can plug in this point and the slope to find b. We get 2 is equal to 6 plus b. To get b by itself, we need to get rid of that 6. We'll subtract 6 on both sides. We get negative 4 equals b. So we know it's of the form y equals mx plus b. We said our slope was 3, and the y-intercept is negative 4. So our line will have the equation y equals 3x minus 4. So let's go back to the problem. So it's 3x minus 4. So notice it's plus a negative. That's how we would put in minus 4. All right, so that's part B. Graph the line found in part B on the scatter diagram. All right, so which one was the one we did? We did this one here. So it's going to have 3 dots at the bottom. Looks like, and it's got that scale of 20. It's going to be this one here. All right, let's go to the next slide. By hand, determine the least squares regression line. We will not do that by hand. Let's go ahead and click here, go to StatCrunch. Notice we have 5 data points. I guess that's not going to matter on this problem. So we got to choose X and Y. And let's go ahead and compute. Make this a little bigger. And we'll I'm going to write down this equation real quick. It's y equals 3.023x. If we round to 3 decimal places, it's 3.0232 minus the y-intercept is negative 4.3023 or 302. All right, so let me go back. So 3.023x plus a negative 4.302. So let's go ahead and check our answer. Graph the least squares regression line on the scatter diagram. So let's go ahead and look at our graph. We go back here, it's on the second page, and I'm going to go ahead and make this a little smaller so we can hopefully look at both at the same time and see which one is the right one. So it looks like it's this one here, but we can't see the other part, and I just lost my other graph. Alright, so that definitely looks like the one, so that's A. Well, maybe I guessed wrong there. Let's see. I thought it was that one, but again, those scales can mess you up sometimes. So I thought it was this one here, but you can see this point's above the line, so I think that was the problem. Let's see. Let me get that back on there. Again, the scale can really make a difference, because notice if I keep losing it. This time I did lose it. I actually closed it out. All right, let's go grab it again. Regression, simple linear, choose X and Y, compute, there's our graph. We really want to see it while we're doing the other. So it wasn't A. Notice it starts at 2, and it does look like it needs to go up to 20, so it's going to be B or D. And it's going to have to be B because there's 3 dots on the bottom there. All right, finally we got that one. All right, so let's go compute the sum of the squared residuals for the line found in part B. All right, so I'm going to go back to my scratch paper. There it is. So here's how we do that. We're doing it for that equation we got, y equals 3x minus 4, because it said the one that we did in part B. So, oh goodness, I need to go back to the table. I didn't put that down. So let me just write in, I'm going to write in my x and y values here. Okay, so let's switch back. So I put in the points. Now y hat is going to come from here. So when we plug in 2, 3 times 2 is 6 minus 4, we get 2. So notice when you subtract these y minus y hat, that's going to be 0, and 0 squared is of course 0. When we plug in 3, oops, I think that's a 5. 3 times 3 is 9, minus 4 is 5, so we're getting 5 again, so that's going to be another 0, 0. When we plug in 4, we get 3 times 4, which is 12, minus 4 is 8. So notice if you take 7 minus 8, which is negative 1, and we square that, we're going to get 1. And then if we plug in 6, we're going to get 18 minus 4, which is 14, so 0 and 0 here. And if we plug in 7, 21 minus 4 is 17, so again we'll get 0. So our residuals squared add up to just 1. So let's go back to the problem and plug that in. All right. Let's see, compute the sum of the squared residuals for the least squares regression line found in part D. Now that's the part that we had the computer do for us, or I should say StatCrunch do for us. I'll go back to what we did here. So if we go back here, it's going to be this value right here, the SS under error. And so that is 0.791 if you round to 3 decimal places, 0.7906. So 0.791. And let's go ahead and put that in. 0.791. And there you go. I think that was, oh wait, there's one more. Comment on the fit of the line found in part B versus the least squares recession line found in part D. So this is going to be true in general. The line in part B passes through the most points. It went through 2 points. If you look at our line here, it doesn't actually go through any points. It's very close, but number 2, it goes through 2 points. We know that. The line in part D minimizes the sum of the squared residuals, thus being the best fitting line. All right. So that is what the least squares regression line is. It's the line where the squared residuals have the smallest value, or it's minimized. All right, so that's it for those two. We'll go ahead and stop right there.